Okay, so in this guided activity, we're going to copy and paste certain cards right here on slide 2 to slide 3. Okay, and so the first thing I want to do is look at slide 3. I want to identify what kinds of boundaries and what kinds of crust I'm looking at here. So I'm going to label all of these, and it'll be easier to tell what type of boundary we have. Notice that they're kind of different shades. You can definitely see it here. This one is darker than this one. These two are the same shade. These are the same shade, and these are the same shade. They did it in different shades to illustrate the different types of crust. Okay, so I labeled each of the plates with a blue dot or a green dot. The blue dot represents that this is oceanic crust, and the green dot represents the continental crust. So in this first image, this first boundary type, the arrows are pointing away from each other, and it's oceanic crust. So when your arrows are pointing away, when they're dividing, it is a divergent boundary. So I'm going to come to my answer choices and type of boundary. I'm going to go find the divergent, and I'm going to copy it, and I'm going to paste it onto this page. So I just need to drag it over here. So this is a divergent boundary. And the next step is to determine what happens at a divergent boundary with oceanic crust. So when two pieces of oceanic crust divide and slide away from each other, they divide apart, they go apart. Magma fills up this divide. So magma comes up through the surface and fills up right here. And that, when it reaches the ocean surface, it creates new rock. And we call this seafloor spreading, which is where we create new oceanic crust. So as the arrows point away from each other underwater, magma comes up through that divide and it creates new ocean floor. And we call that seafloor spreading. This divide is different than a trench or a fault, because magma is coming up and filling that divide. It's just an opening for magma to come through the ocean crust, whereas a trench is just a deep hole in the ocean floor. There's no magma coming up through it, and a fault is not very deep at all compared to a trench or a ridge. So at an ocean ridge where the divergent oceanic plates are separating, magma is filling that divide. So I'm going to go to slide 2 and find my seafloor spreading new crust, because that is what's happening at this. The next thing we need to identify are the land features or occurrences. So what's created at a divergent boundary depends on if the boundary is occurring on the ocean floor or on land. When it occurs on the ocean floor, you get a ridge, an ocean ridge. When it occurs on land, you get a rift valley, okay, a rift valley. And so I'm going to go to my answer choices and look for land features and occurrences and find something that's similar to ocean ridges or rift valleys. So I cut that and I'm going to paste it. And this says ocean or continental rift valleys. But it's really important to know that this is also where ridges occur, ocean ridges. And when we go look for our places on Earth where this occurs, we'll see we have the Great African Rift Valley, the Mid-Atlantic Ridge. Atlantic is the ocean. And then there's Iceland, which we've talked quite a bit about. And it is the volcanic island that is being split into two. So I'm going to copy that, and I'm going to come here and I'm going to paste this. Okay, so that is the complete set for our divergent boundary. The plates, oceanic plates, are splitting apart, which is allowing magma to come through that divide and create new ocean crust, and this is called seafloor spreading. And then that's going to create ocean ridges. When the continent splits, when there's a divergent boundary on land, you get your rift valley. And then these are our examples of this boundary. The next boundary we're going to talk about is this one, and what I notice is I have two arrows pointing toward each other. These two arrows pointing toward each other tells me that this is colliding. So this is a convergent boundary. And then I have a blue dot and a green dot. The reason I know that the blue dot belongs on this plate is because this arrow is showing the plate being pushed under this one. And so we call that subduction. That's the process. So we have a convergent boundary between land and ocean where subduction is occurring. This arrow is telling me this plate is sinking under this plate, and that's going to create a trench and a volcano. But keep in mind, this is continent. This is a big piece of land, so we're going to get more than just a volcano. We're going to get a lot more land interaction. So I'm going to go find the two pieces that I need right now. So for type of boundary, I'm looking for convergent, ocean, and continental, and that's going to be this second one. I'm going to copy that and paste it. And then what's happening is subduction, okay, where old crust is being recycled. So this crust down at the bottom of the arrow is being melted back down into magma, and it's going to be pushed up through that volcano. Okay, so I'm going to go to what's happening, and I'm looking for old crust recycled or destroyed, and I'm looking for subduction. Subduction is your big keyword, and I see that right here. So I'm going to copy that and paste it. And then I've mentioned it a few times already, but when we have subduction, we have several things that occur. That we'll have a trench and we'll have a volcano. And then because this is continent and ocean, we're going to get coastal mountains. These volcanoes are going to occur along the coast. Okay, so continent and ocean, land and water, will create coastal mountains, volcanoes, and trenches. So I'm going to come to my answer choices for land features, and I'm going to look for that. So I have trenches, volcanic islands, and island arcs, and then I have coastal volcanic mountains, like the Andes Mountains, island arc, like Japan, and then trenches. So I think this is the one I want. I'm going to copy it, and I'm going to paste it. And then I want to find famous land formations that match my land features. So I'm going to look for a coastal mountain range and maybe a trench. So I come back to my answer choices, and in this last column, the very first one says west coast of South America. So that's telling me, hey, I got coastal mountains. They're actually called the Andes Mountains, which is the name right below that. So this is the one that I want. When we have a convergent continental and oceanic boundary, we get coastal volcanic mountains off of, just like the ones off the coast of South America. The next boundary we have is also convergent, and I know that because my arrows are pointing to each other. This arrow is demonstrating that this plate is being pushed down, and both of these pieces are the same color, so I'm going to assume they are the same kind of crust. So I put a blue dot on both, because when we have oceanic and an oceanic plate collide, one of those plates is pushed down underneath during subduction. So there's subduction occurring here. So I need to go find a convergent oceanic boundary. That one's continental. So it's this last one. I'm going to paste that. And then I'm going to go find what's happening on the crust. Because we know subduction's happening, we know that old crust is being destroyed and the ocean crust is being subducted. So subduction is the process of recycling this old crust. As this oceanic plate is pushed under, it's melted back down into magma, and that magma is pushed up through that volcano. Okay, and we also get a trench here. So let me go find that. Old crust destroyed, ocean crust is subducted. That is the one that I want. I'm going to cut that and paste it. and then I need land features. So we know with subduction we get volcanoes, we get trenches, but when it's ocean, those volcanoes are going to grow and be pushed above the water to form islands. So I know that when it's ocean, I'm going to get some islands. So I'm going to come to my answer choices, and the very next one are trenches, volcanic islands, and island arcs. So I'm going to copy that one. Again, when that oceanic crust is subducted, it is melted back down into magma and forced up through that volcano. And over time, that volcano gets bigger and bigger and bigger and eventually is pushed above the ocean to be a little island. And that island will grow. And our example of that are going to be our Aleutian Islands in Alaska. That's what happened in Alaska. So I'm going to cut that and paste that here. And we are done with our subduction boundaries. Okay, so to summarize these last two, both of them are examples of subduction. The more dense oceanic plate is pushed underneath the other plate, and that recycles that old crust to create a volcano and a trench. Now, when it's ocean and land, you get coastal mountain ranges. When it's ocean and ocean, you get more islands because that volcano is eventually pushed up above the ocean. Our next boundary are convergent as well. These two arrows are pointing directly at each other, but there's no subduction happening. And what I see right here is I see little hill-like mountain shapes. So because these are the same shade as this land, I'm going to assume that these are continental plates and they are colliding. And what happens when they collide, because they are the same density, they are going to push up, and basically the land will change its shape. That piece of crust will turn into a mountain. And so it'll go from being two flat continents to when they collide, they fold up and gain peaks and different things like that. So they end up having a different shape. So I'm going to go look for a converging boundary that is dealing with land and land in my answer choices. And that's going to be this first one, convergent, continental, continental. So we have two pieces of land colliding into each other. And that's going to cause the mountains to change shape as they fold up. So if we look at our answer choices, they're a little difficult to tell the difference between. So this first one says crust is neither created or destroyed, and the crust is deformed. And this other one says shearing, and then it says that the crust isn't created or destroyed, but deformed. So for shearing, I want you to think of shearing like cutting. Scissors are also called shears. So when we use scissors, we cut things. When plates shear, they're cutting. And I want you to make the cut association with the transform boundary. So the correct answer for the boundary I'm currently working on is this one. The crust is just deformed. So what happens when two continental plates push up against each other? The land goes from being flat, the continental crust goes from being flat to turning into mountains. So its shape changes. The crust is not recycled or created. It's the same old continental crust, it's just been misshapen into the form of a mountain. Okay, and with that being said, the land feature are going to be our folded mountains, continental folded mountains. You can even Google pictures of folded mountains and see where it even looks folded. Okay, and our example, we've talked a lot about it. It's the tallest mountain in the world, or where the tallest mountain in the world is, and that's the Himalayan mountains. The Alps are also another example, but the Himalayan mountains are the most famous. That's where Mount Everest is located, and that's the tallest mountain in the world. Our last boundary is a transform boundary, where these plates are sliding past each other. And the thing I want you to notice the most is that these plates are side by side. They're not running into each other. There's no divide. They're just side by side. So if you take your hands and you put them side by side and you move one hand, you put pressure, they're tightly side by side, and you move one hand forward and the other hand back, you can feel that friction. You can feel the rubbing between your hands. That's what happens with the plates. They are side by side, one's moving up and one's moving down, and they rub on each other like that. And so what happens is it cuts up. So it's like when you slide on your knees and your pants rip. These two plates slide past each other, and so it causes tearing or cutting, okay? So at this transform boundary, let me go copy and paste that boundary name. At a transform boundary where the plates are sliding, it causes shearing or cutting. Shearing and cutting are essentially the same thing, okay? And it causes the crust just to kind of break and cut. So it changes its shape a little bit and creates that fault line. That fault, we need to describe it like it's a cut in the Earth's crust. It's not as deep as a trench. It is not a ridge. There is not magma coming up through it. It's just like a little crack in the ground. If you ever go outside and look at the dirt when it's really dry and you can see little cracks in the ground because there hasn't been any rain, that's basically a baby fault, like a miniature fault. In California, where the San Andreas Fault's located, that's what it looks like. For the size of the plates, that's a little break in the ground. It's just a cut. So at a transform boundary, the plates slide tightly past each other, and this causes shearing or cutting. And this will create your fault. This also creates earthquakes, but it needs to be understood that earthquakes occur at every boundary type. Okay? Earthquakes are more severe at these boundaries, at a transform boundary. But the big land feature that is created due to this shearing or this cutting is going to be your fault. And just like the movie, the San Andreas Fault is your best example. It is one of the more famous fault lines in the world. Okay? So now our table is complete, and you guys can use this to complete your own table as well as the follow-up questions that will be taken for a grade. If you're doing this activity and you accidentally delete some of these pieces, on slides 5 and 6, I have 2 extra copies where you, in case you are missing pieces. And then you can also always use Control Z or this undo arrow that's in the upper left corner of your assignment. Okay, and don't forget to use this to complete the follow-up questions for RM 39, determining plate boundaries.